Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AMIRUDDIN bin ARIF. 2200373 from Monte MT1 will present the answer for question 2 and 3. Okay, so the first question is definition of inductor. Okay, what is inductor? Inductor is passive to terminate electrical component that stores energy in a magnetic field when electric current flows through it. Okay, the next question is what are the methods to increase its inductance value? Okay, we can increase its inductance value by winding the wire into the coil. Also, we can increase the coilton and increase the cross-sectional area of the magnetic core to increase its inductance value. Okay, for the next question is what are the application for inductor? Okay, as we know, application of inductor are induction motors, also transformers, and other than that, inductive filters. Okay, for the number 3, the question is definition of capacitor. Okay, what is capacitor? Capacitor is a device used to store an electric charge consisting of one or more pairs of conductors separated by an insulator. Okay, for the next question is what are the methods to increase its capacitance value? Okay, we can increase the capacitance value by change it with the larger plate. Also, we can increase the surface area, reduce the separation between the plate, and use a dielectric material in between the plate which have higher dielectric breakdown strength. Okay, what are the application of capacitor? We can, as we know, capacitor is used in wide range of industries. So that's all for me. Thank you.
Assalamualaikum and good evening to everyone who watch this video. Hari ini saya akan menerangkan tentang soalan 4A dan 4B. Okay, untuk soalan 4A, under DC condition, we replace the capacitor with an open circuit and the inductor with a short circuit. It is evident that I sama dengan IL. So kita suka nilai 12/1/5 sama dengan 2 ampere. The voltage VC is the same as the voltage across the 5 ohm resistor. Hence, VC sama dengan 5I sama dengan 10 volt. For the question B, the energy, we need to find the energy in the capacitor. So we use the formula 1/2 CVC square. Masukkan nilai 1/2, 1, 10, gantikan je 10 kuasa 2. So we got 15 joule. And the energy for the inductor, use the formula 1/2 Li. L kuasa 2. Masukkan nilai 1/2 Li 2 L 2 kuasa 2. So we got 4 joule.
Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera saya ucapkan kepada semua. Okay, hari ini saya akan menjawab soalan nombor 5. Soalan dia, obtain the energy stored in each capacitor in figure 3.12a under DC condition. Okay, under DC condition, we replace each capacitor with an open circuit as shown in figure 3.12b. The current through the series combination of the 2 kW and 4 kW resistor is obtained by current division as I 3/3 plus 2 plus 4 times 6M equal to MA. Okay. After that, hence the voltage V1 and V2 across the capacitor are V1 we get 4 volt, V2 we get 8 volt. So the energy stored in them are for V1 equal to 1/2 C1 V1 V21 equal 1/2 times 2 times 10 kuasa negatif 3 times 4 square equal 60 mJ. W2 1/2 C2 V22 equal 1/2 darab 4 darab 10 negatif 3 darab 8 kuasa 2 sama dengan 128 MJ. Sekian saja daripada saya untuk soalan 5.
So good evening to the lecturer. Today I'm going to present the active and passive component comparison. Active component, can we see nature of source. Active components deliver power or energy to the circuits, and the function of components, devices which produce energy in the form of voltage or current. The power gain, for the active component, they are capable of providing power gain. Example of the active components is diodes, transistor, SCR, and integrated circuits. For the passive component, nature of source, passive elements utilizes power or energy in the circuits. Function of the component, devices which stores energy in the form voltage or current. Power gain, they are capable of providing power gain. Example of the passive component, resistor, capacitor, inductor. Next is the difference between the series and parallel circuits. Series circuits, the same amount of current flows through all the components. In an electrical circuits, components are arranged in a line. When resistors are put in the series circuits, the voltage across each resistor is different, even though the current flow is the same through all of them. If one component breaks down, the whole circuit will burn out, and the voltage total equal like V1 plus V2 and plus V3. For the parallel circuits, the current flowing through each component combines to form the current flow through the source. In electrical circuits, components are arranged parallel to each other. When the resistors are put in a parallel circuit, the voltage across each of the resistor is the same, even the polaritaries are the same. The components will function even if one component breaks down, each has its own independent circuit. And if V total, voltage total is equal to the V1 equal V2 equal to V3. The next slide is comparison between independent sources. The sources, the energy produced by them depend on the parameter in the circuits are called the dependent sources. The sources, the energy produced by them don't depend of any other parameter in the circuits are called the independent sources. And the independent voltage source maintains voltage is or varying with time, which is not affected by any other quantity. Some voltage current sources have their voltage current values varying with some variables. They are called dependent voltage current source or controllable voltage current sources. Next is the comparison between Ohm's law and the current divider rule. For Ohm's law states that the current through the conductor between 2 points is directly proportional to the voltage across the 2 points. And the equation is we see I equal to VR, where I is the current through the conductor and V is the voltage measured across the conductor and the R is the resistance of conductor. Ohm's law states that R in this relation is constant. For the current divider rule, current divider is a simple linear circuit that produces an output current IS that is a fraction of input current IT. The current in the various branches of such a circuit will always divide in such a way as to minimize the total energy expended. Current division refers to the splitting of current between the branches of the divider. Next is the comparison of Kirchhoff's current law and the Kirchhoff's voltage law. With Kirchhoff's voltage law, KCL, a sum in the current entering the node in the circuit and node in the point where branch connection in the circuits come together. The sum of current entering the node must equal the sum of the current leaving the node. Typically, all currents are treating as leaving the node and the sum is set to 0. Current entering the node will simply get a negative sign when so. With Kirchhoff's voltage law or KVL, we are summing of voltage around the closed loop in the circuit. The sum of voltage around any loop must equal to 0. And that's all from me. Thank you.